because I have quite a few friends that have Lyme disease, and it's something you do keep for life. Long Island's overwhelmed with Lyme disease.
And they got a new tick, apparently, that prevents you from eating meat?
Yes.
I wonder if the vegetarians bred that.
No, well, I think it's called the Lone Star tick, and it
prevents you from eating the meat of mammals.
It makes you allergic to alpha galactose. Quite a few friends, like 7 or 8, I think at this point, that have devastating Lyme disease, and it's all East Coast people going around, going for a hike.
Yeah, I'm a city person.
Don't you want to go wander around a little bit?
Well, what I know is that I attempted to call their attention. After the report came out, I looked at it, and it had a physical form, but it lives online. You can search it. And I could see that telomeres weren't mentioned, mice weren't mentioned, rodents aren't mentioned. And so I tried to alert them to the fact that they had screwed up, and they blew me off. They wouldn't talk to me.
Something dangerous has been developing in the United States for over a century, and no one saw it coming. Now, with the risk of a disease that could wipe out the country's entire population, scientists are racing to find a solution. However, these solutions might be even deadlier than the threat itself. Just how dangerous could this be? What exactly is this hidden danger that threatens the nation? Join us as we uncover the mysteries behind the threat that was unleashed in the U.S., the growing danger. A recent episode of the Joe Rogan podcast revealed something strange and alarming, a scientific experiment that may have gone too far. In this episode, Joe Rogan invited evolutionary biology professor Brett Weinstein, who shared that an anonymous hacker recently accessed confidential documents, emails, and reports from a research institute in Massachusetts. Based on this information, the United States might be facing the risk of an invasion or even a potential pandemic. These documents suggested that scientists are preparing to release thousands of genetically modified mice into the public. While this could be a promising step toward building resistance against the deadly Lyme disease, the secrecy surrounding the plan has raised serious concerns. Why mice? Rodents, especially mice, have been a staple in medical research for over 50 years. Although using animals in experiments has sparked ethical debates, lab mice have contributed to major scientific discoveries because of their genetic and biological similarities to humans. However, their role in research extends beyond simply replacing humans in laboratory studies. The use of mice for scientific purposes may not seem alarming, but the idea of releasing genetically altered versions into the public is, regardless of the reasoning behind it. But the situation becomes even more unsettling. A particular conspiracy theory involving the Plum Island Animal Disease Center has gained attention, suggesting that Lyme disease might actually be a bioweapon that the U.S. military has been trying to contain. If true, this would mean the danger isn't coming from an adversary, but from U.S. laboratories themselves. In the 1960s, on a secluded 840-acre island at the entrance of Long Island Sound, scientists at the highly secure Plum Island Animal Disease Center were at the forefront of U.S. biological weapons research. Their objective was to develop harmful pathogens that could be discreetly transmitted through insects. Fast forward to 1965, when the nearby town of Old Lyme, Connecticut, became the center of a puzzling outbreak spread by ticks. Children began developing unusual skin rashes, persistent fatigue, and swollen knees. By 1968, this mysterious illness was named Lyme disease. A controversial theory emerged, suggesting that scientists at Plum Island had engineered this new disease, which now impacts over 30,000 Americans annually. In 2020, Congress decided to investigate this claim by adding an amendment to the National Defense Authorization Act, and what they uncovered was shocking. Beyond Joe Rogan's discussion, Representative Chris Smith from New Jersey, who introduced the amendment, strongly believes there is truth to the theory. Smith has long pushed for deeper research into the origins and treatments of Lyme disease. His stance is influenced by well-known books such as Lab 257 by Michael Carroll and Bitten by Chris Newby. In Bitten, Newby interviews Willy Bergdorfer, the scientist who first identified the bacteria behind Lyme disease, Borrelia burgdorferi. Smith thinks there's too much evidence for this to be just a conspiracy theory. However, Plum Island officials have repeatedly denied these claims, rejecting the idea that they played any role in the outbreak of this deadly disease. In a 2004 article, the lab's former director, Roger Breeze, dismissed these allegations, arguing that the author of Lab 257 was making things up to gain attention and sell books. But the situation gets more complex when Richard Pilch, an expert on chemical and biological weapons, acknowledges that there is evidence both supporting and contradicting the theory that Lyme disease could be linked to research at Plum Island. He notes that the island's proximity to Lyme, Connecticut, where the disease was first identified in the 1970s, raises questions. Additionally, records show that scientists at Plum Island were studying pathogens that could be spread by insects. However, Pilch also points out that Borrelia burgdorferi, the bacterium responsible for Lyme disease, existed in North America long before it was officially discovered. For example, it was found in a 5,300-year-old mummy, proving that the disease had been around far earlier than the 1970s outbreak. Whether old or new, the question remains, what kind of impact will releasing this new species have? Out of the frying pan into the fire. Now the military has stepped in to correct past mistakes, but according to an anonymous guest, the scientists may have realized that their genetically modified mice could be more harmful than they initially thought. Instead of addressing the issue, they allegedly covered it up, insisting it had already been dealt with, an odd way to dismiss something that could turn into a major problem. Joe Rogan's podcast has made people question the real motives behind these experiments and what could go wrong. Documents reveal that the effects of releasing these modified mice might not be noticeable for a year or more, meaning there wouldn't be any immediate changes in Lyme disease rates or the tick population. It appears that scientists are just making assumptions while acting as if they have all the answers. In the meantime, people would have to put up with an overwhelming number of mice for over a year without any certainty that the plan would even work. Instead of using that time to develop better treatments, they chose to flood the area with mice, which may explain why they kept the project under wraps. Once the public found out, the scientists reassured everyone that the mice would first be tested in unpopulated areas, which sounded reasonable but may have been a tactic to ease concerns. Some biologists have warned that these genetic modifications could lead to serious health risks, but the scientists seem to be withholding the full truth. On Joe Rogan's podcast, the guest also mentioned that all the mice used in these experiments came from the same lab, meaning they might react predictably in a controlled environment. However, once released into the wild, where conditions are unpredictable, the outcome could be entirely different. One concern is that the parasites might stop infecting mice and start targeting other animals, leading to new diseases. Additionally, these modifications could cause the germs to evolve into stronger strains, affecting both modified and unmodified mice. This could potentially trigger a disease outbreak that harms both wildlife and humans. Another issue is that wild mice could breed with genetically modified ones, mixing their genes into the wild population. This could result in hybrid mice with unknown behaviors and effects on the ecosystem, possibly leading to the loss of original natural mouse genes. These hybrids might even grow larger and faster than regular mice, creating further complications. The release of documents exposing these hidden risks has raised many questions about the scientists' awareness of potential consequences. Did they consider these risks? It appears they focused only on short-term effects while overlooking possible long-term dangers. In scientific research, openness and public involvement are essential, especially when dealing with genetic experiments that could affect both the environment and public health. The public has a right to know about such experiments, yet the scientists proceeded with a risky study without fully considering its consequences. While genetic modification has significant potential benefits in medicine, agriculture, and environmental protection, it also carries risks. This is why ethical discussions and public input are necessary before making major decisions. These leaked documents have added to the confusion about the truth behind this conspiracy theory, which leads to another important question. What exactly is Lyme disease, and where did it come from? As mentioned earlier, the earliest known evidence of Lyme disease was found in a 5,300-year-old mummy named Ötzi, discovered in the Eastern Alps. Scientists have traced the history of Borrelia burgdorferi, the bacteria responsible for Lyme disease. Research suggests that before the reforestation of New England and westward migration in the early 1800s, Lyme disease had existed in America for thousands of years. It spread alongside ticks from the Northeast to the Midwest. In the 1600s, explorer John Josselyn noted that New England had many ticks, describing how they clung to people's clothes and bit through their skin. Similarly, in 1749, Swedish botanist Peter C.M. observed ticks in New York's forests. However, by the 1800s, widespread deforestation may have isolated Lyme disease to a few coastal and Midwestern areas. These were only scattered reports, though. The first detailed account of Lyme disease symptoms was recorded in 1764 by John Walker, who visited a Scottish island and described limb pain linked to a small reddish creature, likely a tick. Many people from this region migrated to North America in the 1700s, possibly bringing the disease with them. Borrelia DNA has also been found in an 1884 tick from Germany and a mouse from Cape Cod that died in 1894. When Ötzi's body was examined in 2010, scientists found that he carried the DNA of the Lyme disease bacteria, making him the earliest known case in Europe. Doctors began identifying Lyme disease symptoms in the 1800s. In 1883, a German physician documented a man with a skin condition now recognized as acrodermatitis chronica atropicans. By 1909, Swedish doctor Arvid Elias named the rash that followed a tick bite erythema migrans. Over the next few decades, researchers in Europe and America started linking tick bites to neurological and skin-related symptoms, eventually discovering that penicillin could be an effective treatment. Lyme disease was first identified in the United States in 1975 when a group of cases, initially mistaken for juvenile arthritis, was found in Connecticut near the towns of Lyme and Old Lyme, which led to the disease being named after them. Researchers and doctors continued to study it, learning how it spreads through tick bites and developing treatments. The most recognizable sign of Lyme disease is a red rash called erythema migrans, which typically appears about a week after being bitten. This rash does not cause itching or pain, and around 70 to 80% of infected individuals develop it. Other early symptoms may include fever, headaches, and extreme fatigue. If left untreated, the disease can lead to complications such as facial muscle weakness, joint pain, a stiff neck, and heart problems. Some people may also feel shooting pains or tingling sensations in their arms and legs. In the U.S., Lyme disease is primarily transmitted by the Ixodes scapularis tick. For the bacteria to be passed on, the tick must stay attached for at least 36 to 48 hours. But if removed within 24 hours, the risk of infection is very low. In Europe, a different tick species, Ixodes ricinus, is capable of spreading the bacteria more quickly. The disease is not contagious between people, animals, or through food. Doctors diagnose Lyme disease by evaluating symptoms, checking for tick exposure, and sometimes using blood tests to detect antibodies. Since early blood tests can occasionally produce false negatives, testing the tick itself is not generally useful. Preventing Lyme disease involves avoiding tick bites by wearing long clothing and using insect repellents containing DEET or picaridin. Removing ticks with tweezers as soon as possible is crucial, and if a tick is engorged with blood, a doctor may recommend a single dose of doxycycline to prevent infection. If Lyme disease develops, antibiotics such as doxycycline, amoxicillin, or cefuroxime are used for treatment, typically lasting 2 to 3 weeks. Lyme disease is the most common tick-borne illness in the Northern Hemisphere, especially during spring and early summer. It was first identified in 1979 in Lyme, Connecticut, and was originally thought to be a type of arthritis. The bacteria responsible were discovered in 1981. Some individuals experience lingering symptoms after treatment, known as post-treatment Lyme disease syndrome, which is distinct from chronic Lyme disease, a term that is no longer used by scientists. As of 2023, no human vaccine was available, though some were being tested. A vaccine called Limerix was once offered but was discontinued in 2002. However, vaccines exist to protect dogs from Lyme disease. Scientists continue to search for ways to eliminate the disease entirely. How widespread is the problem? How dangerous is Lyme disease? Around 80% of infections start with a rash at the site of the tick bite, often in areas like the armpit, groin, or behind the knee. Many people do not recall being bitten. The rash usually appears 1 to 2 weeks after the bite and expands by about 2 to 3 centimeters per day, sometimes reaching up to 70 centimeters. It is typically round or oval, red or bluish, and may have a darker center. In Europe, a bullseye pattern is more common, while in the US it appears less frequently. The rash may feel warm to the touch, but is usually not itchy or painful, and it can take up to 4 weeks to disappear if untreated. In some cases, people with the rash also experience flu-like symptoms, such as fatigue, headaches, muscle aches, fever, and chills. These symptoms can also occur without a visible rash, meaning Lyme disease may progress without obvious signs. People who have had a fever for more than 2 days or whose symptoms don't improve, despite treatment, may be tested for other tick-borne illnesses. Not everyone with Lyme disease experiences all the symptoms, and many of them overlap with other conditions. Fewer than 7% of infected individuals in the United States show no symptoms, though this appears to be more common in Europe. In some cases, the bacteria can spread through the body within days or weeks. New rashes may develop in different areas, and muscle or joint pain is frequent. If left untreated, Lyme disease can lead to neurological issues such as headaches, neck stiffness, sensitivity to light, facial paralysis, or nerve pain. Some children may also experience partial vision loss. Some individuals suffer from severe pain, especially at night, along with sleep disturbances. Facial paralysis occurs in about 5 to 10% of untreated cases in North America and is often accompanied by headaches. Nerve pain is less common but may go unnoticed. In Europe, some untreated cases show a combination of headaches and nerve pain more frequently. Lyme disease can affect the heart, leading to palpitations, dizziness, fainting, and shortness of breath. It may also interfere with the heart's electrical system, causing irregular rhythms. Other symptoms such as joint pain and headaches may also be present, but for some, heart problems are the first noticeable sign. In Europe, a skin condition may appear months after infection, forming purple lumps on the ear, nipple, or scrotum. If left untreated, joint swelling and pain may develop, often affecting large joints like the knee or hip. The pain is usually mild but can come and go. In some cases, fluid-filled cysts may form and burst. Nerve-related symptoms, including numbness or tingling in the hands or feet, have been reported but are uncommon. Some individuals have also described memory and concentration problems, though this remains debated and has not been observed in Europe. Rates of depression and fibromyalgia in those with Lyme disease are similar to those in the general population. A long-term skin condition, mostly seen in Europe, can cause the skin to thin and wrinkle, beginning as a reddish-blue patch that worsens over time. As of 2023, there were no available vaccines for Lyme disease in humans. The only vaccine that ever reached the market was LYME-RIX. The U.S. Food and Drug Administration approved Limerix after large trials involving over 10,000 people, but it struggled to gain traction in regular medical use due to its high cost, which was often not covered by insurance. Some individuals who received the vaccine reported side effects, including autoimmune issues leading to lawsuits, despite investigations finding no link between the vaccine and these health concerns. Public fear increased, and the vaccine was eventually withdrawn from the market. After Limerix was discontinued in 2002, a company called Valneva began developing a new vaccine, VLA15, based on the same bacterial protein. In 2020, Pfizer partnered with Valneva to assist in its development, and the two companies launched trials across multiple locations in the US and Europe. They plan to administer 3 doses to volunteers, followed by a booster shot a year later. Research into other vaccines is also ongoing. One experimental vaccine uses mRNA to trigger a rapid immune response to tick bites, allowing the body to remove ticks before they transmit Lyme disease. In animal testing, the vaccine helped protect against Lyme when only one tick was attached, but it was less effective when multiple ticks were present. For dogs, 3 Lyme disease vaccines are available. One contains dead bacteria, while the other 2 use bacterial proteins to help the immune system eliminate the bacteria before infection occurs. Treatment for Lyme disease primarily involves antibiotics. Doxycycline is typically the first option for early infection, but other antibiotics such as amoxicillin are used for children or pregnant women. Those with more severe symptoms, including joint or heart complications, may require stronger antibiotics, sometimes administered through an IV. In some cases, if symptoms return after treatment, a second round of antibiotics may be required. However, extended treatments beyond 28 days are not recommended as there's no evidence they are more effective. Even after successful treatment, some individuals continue to experience joint swelling or pain. For these cases, doctors may suggest physical therapy, anti-inflammatory medications, or other treatments. This ongoing issue caught the attention of scientists who proposed an alternative solution, tackling a century-old pandemic. At the time, Lyme disease was spreading rapidly on Nantucket, which had the highest rate of the disease. While black-legged ticks were the main carriers, mice were the key transmitters of the bacteria responsible for the disease. The lab mice in the plan were genetically modified to resist the bacteria, meaning they wouldn't spread the disease to ticks, which would then infect humans. The idea came from a professor at MIT who shared it with the Nantucket Board of Health and a group of about 20 residents who supported it. However, some people questioned why only 20 individuals were involved in such a significant decision, especially since they might not have fully understood the risks and benefits. Lyme disease had caused so much damage in the area that people were desperate for a solution. Between 1992 and 2001, Nantucket had the highest rate of Lyme disease in the U.S., with serious outbreaks continuing in the years that followed. The scientists concentrated on white-footed mice, which were identified as the primary source of the disease. These mice transmitted the bacteria to ticks, which then infected other mice and humans. The plan was to use genetically modified mice that couldn't pass the disease to interrupt the cycle between mice and ticks. Scientists believed this would reduce the spread of Lyme disease. To achieve this, they needed to identify the genes responsible for disease resistance in the mice and amplify them, creating a population of mice with strong immunity to Lyme disease. The plan was to release over 100,000 genetically modified mice in batches of 20,000 to 40,000 over the course of a year. If successful in Nantucket, the mice would then be released in larger areas throughout the Northeast. The scientists were confident in their approach, but when the plan became public, many were skeptical. If the idea was so promising, why had it been kept secret? Concerns arose that the risk could outweigh the benefits, as the scientists were experimenting with something unprecedented. Some feared the genetically modified mice could cause unforeseen problems. On another podcast, a guest speculated that the scientists might have been aware of potential risks, but chose to cover them up rather than reconsider the plan. Documents revealed that it could take over a year to determine if the mice reduced Lyme disease or impacted the tick population, making the entire experiment speculative. Critics argued that the scientists seemed more focused on proving their intelligence rather than finding a better cure for Lyme disease. Public frustration grew when it became clear that the scientists had withheld important information about the potential risks. Although they had claimed to test the mice in unpopulated areas first, it was also revealed that scientists found mice to be inadequate models for certain experiments, leading to results that differed greatly from what they expected. An article from the National Library of Medicine supported this view, stating that despite mice sharing many similarities with humans, their genetic and physical differences make it difficult to create accurate mouse models for human diseases. Some people believe that how mice respond to inflammation doesn't accurately reflect how humans do. While this has been debated, researchers often use simple techniques to speed up disease progression in mice or to induce diseases that wouldn't normally occur in them. These approaches have had mixed success in leading to treatments that work for humans. For instance, mice don't naturally develop atherosclerosis unless scientists introduce extreme genetic changes such as removing the APOE gene, which isn't how the disease occurs in humans. Cancer is another case. Although mouse models have overlooked some key aspects of human cancers that develop over time, studies in mice have been essential in uncovering critical immune responses, leading to a major breakthrough in cancer immunotherapy. Even more unexpectedly, the guest claimed that scientists have collaborated with journalists to keep the truth about these mice from the public. Some journalists, after reaching out to experts, lost interest when they realized this, raising concerns about what might be happening behind the scenes. The modified mice carry more severe diseases, and while they might help eliminate Lyme disease, they could also trigger new outbreaks. Given their large numbers, these diseases would spread rapidly, making them more difficult to contain. The guest even suggested that scientists may not be able to control the outcomes of their experiments, potentially causing harm to the entire ecosystem. These genetically modified mice are not only spreading diseases but also overpowering wild mice because they reproduce at a much faster rate. They are likely to replace wild mice, disrupting the natural ecosystem. This could lead to an environment dominated by genetically engineered mice, which is concerning, especially considering their ability to spread new diseases quickly. Beyond their impact on wild mice, these altered mice could also interfere with food chains. With enhanced abilities, including improved hunting skills, they could wipe out their prey too quickly. This could create a severe imbalance, and once their food sources are gone, they might start invading homes and public areas, increasing the risk of disease transmission to humans. While scientists may have controlled these mice in lab settings, releasing them into the wild could lead to unpredictable and potentially dangerous consequences. Thanks for watching. See you in the next video.